Lesson 1.8 in pre-algebra, page number 81. The name of this section is called Area and Volume. It actually covers area, volume, and another term, surface area. We'll get into each one of those three. Area is the amount of space that an area covers, and what we do is we use two dimensions in order to determine area. Area would be how much carpet it takes to carpet your house, how much grass seed it's going to take to seed your yard, that kind of thing. It's two dimensions. It's length and width, or length and height, but it's this distance and this distance being two dimensions. Being two dimensions, the simplest way when you're coming up with something, well, in this case, let's just call it a parallelogram. A parallelogram means a four-sided object with the opposite sides parallel or in line with each other. And the area for a parallelogram is length times width. So if we have a rectangle or a square or a funny shaped object like that, as long as the opposite sides are parallel to each other, which they're parallel, my drawing doesn't show that, but you just multiply the length times the height or the width. In this case, the height would be this distance here, not this sloping distance. But if this were 5, 10 times 5 would be 50. If this were 10 and this were 5, 10 times 5 is 50. If this were 5, and because it's a square, all the sides are the same, 5 times 5, which would be 25. So that's basically what it is when it comes to area. If a can of paint covers 350 square feet, it means that if you were to take a 1 by 1 square and take 350 of them, that gallon should cover 350 of those 1 square foot tiles or areas. So if you're looking at your house and you're trying to figure out how much paint it's going to cost, and you're trying to, how much flooring you're going to want to put down, and let's say your living room is 20 by 16, you would take 20 times 16, get 320 when you multiply, and that's how many square feet of carpet you're going to need. Makes it easier then to figure out so you're not underbuying or overbuying materials. In fact, that's the reason people get paid big bucks, is just to come into your house and measure that, and you can very easily do it on your own. What you run into, though, is sometimes you get some odd-shaped geometric areas here that you're trying to figure out. Let's say that that's a house. In fact, I'm on page 83 at the top. There's a floor plan for a house there, and it gives you a bunch of different sizes. Well, if you know how to figure area, being length times the width, you can figure out how many square feet that house is. Because at the top, that top bedroom is 13 feet across, then 27 feet, and then 10 feet. You add those three numbers up, and you're going to get the total length there of 27, 37, 47, 50 feet. It's going to be 50 feet across the top. Now if you look on the right hand side, it's telling you how long it is from here to here. In this particular one, it's giving you this width here of 31 feet, and then this distance here of 7 feet, so it's going to be 38 feet total here, and it's going to be 31 feet total over here, because this is longer, it's 7 feet longer. So you can start figuring out square footage here by taking 50 times 31, and that's going to give you the area of this rectangle right here. 31 all the way across by 50 all the way across. Well, then later you're going to have to take this little area and find the square footage of that. Well, if you look at the top left, it says that it was 13 feet to here. So that is all the way. So this is 13 feet long. And then bottom right, it says that this was 7 feet long. So 13 times 7 would give you the area of this little box here. 50 times 31 would give you the length of this whole thing here. You add those two numbers together and you get the square footage of an odd-shaped form instead of just a rectangle or a parallelogram. Alright, so let's jump up to page number 84 and deal with volume. Just like this was length times width, 2 dimensions, volume, on the other hand, is 3 dimensions. So not only are we doing length times width, but we're also doing length times width times the height. So volume is 3 dimensions. Area would be the amount of carpet you're going to need on the floor. Volume is going to be how much air you're going to have to heat in that house or in that room, because it's going to be the length times the width, and that's the amount of floor space you have. But now you have to multiply it by how high your ceilings are. So if your ceilings are 8 feet, you're going to have to multiply that times 8 feet. So all of that space inside this cube is going to be volume, or how much water can this cube hold. Okay? That's what volume is. And again, it's just length times width times height. So area is length times width. Volume is length times width times height. So if you look on the bottom of page 84, find the volume of a rectangular solid with a length of 15, width of 3, and a height of 5. They give you 3 numbers there. You're just going to multiply those 3 numbers together and get the answer. Alright, surface area. A little bit different, because we're kind of combining volume and area together and coming up with a new idea. Let's see if I can draw a somewhat seeable cube. I'm going to put a dot here to show hidden lines that, you know, this is going on behind the scenes here. Alright, so the way surface area works is you're going to take the area of each side of your 3-dimensional object, and then you're going to add those areas together. A way that you use this in real life, let's say you've got a bedroom that is 12 feet long by 10 feet wide by 8 feet high, and you're going to paint it, and you want to know how much paint you're going to need. So you're going to have to find the amount of paint for this wall, the back wall, the side wall, and the front wall. And then if you're going to paint the ceiling, you're going to have to find the area of the ceiling. And let's say for some crazy reason you're painting the floor. So you're going to have to find the area of each of those 6 sides, the 4 sides of the walls, the ceiling, and the floor. Find the area of each one of those individually, then add them together, and that will give you the surface area of that room. So for example, if we were to take this box and unfold it, we'd have, see if I can kind of make a somewhat accurate. If I were to unfold this room or this box, let's go, it would unfold to that. 6 sides. So this might be the floor, the ceiling, a wall, a wall, a wall, a wall. So we're going to find the area of this. So if this is 12, 10, so we get 120. And this is 120, the other wall. This is 120, the other wall. And this is 120, the other wall. And we add it to this and this, we end up getting our surface area of that cube. So that is all there is to that lesson, and we'll do some problems to kind of get that to sink in a little bit more on page 87 in the next video in a minute.